Okay, hello math fans. We are going to start on chapter 8 now, and basically the first topic here that I want to talk about is something called domain and range and functions. Okay, so let's actually talk a little bit about domain and range. Domain and range. Domain, if I look at, we have our x, y values. Okay, our domain is going to be x values, and the range are y values. Okay, it's very simple. Just a way to remember that is D comes before R, X comes before Y. So if you just remember alphabetically, that's kind of how you remember domain and range. Okay, D comes before X, R comes before Y. That's it. So let's just start off with a real basic example. If I give you some coordinates, 2, 5, 3, 7, 5, 3, and 8, 4. And I ask you the domain. Okay, it's literally, you're just going to tell me the x values. They don't have to be in any order. It's going to be 2, 3, 5, and 8. And the range are the y values. And it's going to be 5, 7, 3, and 4. Very simple. It's just so easy. Okay, and if I had some things repeated, let's say I had 2, 5, and 3, 5, and 4, 5. Okay, the domain is going to be 2, 3, and 4, and the range is going to be just 5. Okay, you don't tell me 5, 5, and 5. It doesn't really make sense to tell me that's what the range is. It's just like if I said, how many people have a name of Joe, and somebody says, well, I have a name Joe, and then another person says, I have a name Joe. I just want to know the number of people. It doesn't really matter that there are that many. If I listed all the names on the board, I'm not going to write Joe, 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 Joe. I'm just going to list Joe one time. Okay, so that's domain and range. Let's talk about if something is a function. And we'll do this with coordinates first. Okay, basically, if it's a function, if the x values, that's huge, x values don't repeat, then the points represent a function. That's it. If the x values don't repeat, then the points represent a function. If they do repeat, if one x value repeats, then it's automatically not a function. Real simple. So that's what the question is going to be. It's going to look like this. I'm going to say, do the following coordinates represent a function. Okay, and it's going to say, 2, 5, 3, 6, 8, 2, and 7, 5. Hey, well, you're going to look and you're going to say, well, let's see. First of all, let's just write this out. The domain is 2, 3, 8, and 7. Okay, so right away, remember domain are x values, and so yes, the answer is yes. It's a function. And let's just look at a range. It's 5, 6, 2, and 5. Oh, there's a 5 repeated, but that doesn't matter. Okay, the 5, you could have everything repeated for a range, and it's still a function. So that is, your range is going to be 5, 6, and 2, and that's fine. But yes, the answer to this one is yes, it's a function. Okay, let's start another example here. And it's going to be the same question. Do these points represent a function? So 2, 5, 8, 3, 7, 6, negative 4 comma 1 and 2 comma 13. Alright, and basically just looking at it, here's your domain again. It's 2, 8, 7, negative 4, and there's 2. Oh, there it is, man, right there. The 2's repeated, so this is not a function. Real easy, and obviously my domain is still these values here, but since the 2 is repeated, it is not a function. Okay, and then of course our range is going to be 5, 3, 6, 1, and 13. Okay, so I can give you, just real quickly, 2 comma 5, 3 comma 5, 4 comma 5, 5 comma 5, 6 comma 5, okay, etc. Keep going, right? And you would recognize right away that the x is not repeated. 2, 3, 4, 5, 6. The y is repeated. I don't really care. So my answer is yes for this one. Okay, pretty easy. All right, so let's talk about how about graphically? If I give you a function that looked like this, and I ask you, is this a function? All right, let's look at a couple things about this graph. First of all, if you remember what I just taught you, it's a function if the x values do not repeat. Okay, so if the x values don't repeat, it is a function. So let's just kind of pick off a couple points here. Okay, let's look at this point right here. The value of this point is 0, comma 3. The value of this point right here is 0, comma negative 3. Oh, there we go. That's 0 and that's 0. There are two x values that are repeated. Okay, so is this a function? No, it's not. Okay, because those two x values are repeated. And the way you can tell with a graph, because if you notice here, if I just even look at this point right here and this point right here, you know, here the x value is negative 2, so this is negative 2 comma 2, and this is negative 2 comma negative 2. So again, you can see it's x values again are repeated. Now the deal is, you can see if I give you a point right here, I can give you another point down here with the same x value. So we're going to do something called a vertical line test. And if you notice, when I did this problem here, the x values, you can just see they're right above each other. Okay? So if I actually draw a vertical line, and this is with the vertical line test, if you can cross the graph in more than one place, drawing any vertical line, if it happens one time, it is not a function. Okay? So let's write that in here. If a vertical line intersects any two or more points, okay, and I should say that if any vertical line, no matter what, if it happens one time, so if vertical line intersects any two or more points, then the graph is not a function. Okay, and just kind of put in parentheses here, it can be if any vertical line happens, or if any vertical line crosses, then not a function. If any vertical crosses, of course, two or more points. Okay, so if any vertical line crosses 2 or more points, or or 2 more places on that graph, then it's not a function. All right, so let's do a couple of demos here. Okay, if I give you a graph like this, okay, does that represent a function? Well, here, just draw here. Oh, intersection one time here, one time here, one time here, one time here. Okay, so no matter where I draw a vertical line, it's only hitting it in one place. So the answer to this one is yes. Okay, it's pretty easy. So let's do another one. Look at that graph. So same thing, just going to draw a bunch of vertical lines. Hits it one place, one place, one place, one place, one place. Hits it in one place, so this is yes. Okay, let's try a few more here. Here's a graph. Okay, and if we draw, that one's good, that's okay. Oh! Actually, this one hits it in 1, 2, 3 places. Okay, as soon as it hits in more than 2 places, or more than one place, I don't even need to keep drawing vertical lines. I know this answer is no, it's not a function. All right, what about this line? Is that a function? Well, of course it is. It only hits it in one place each time. So this is yes. Okay, what about this one here? This is, maybe like y equals 2. Okay, well, of course, that one's good too. Okay, so that one's yes. Here's another one here. How about a vertical line? Is that a function? Well, no, it's not, because if I do the vertical line test, it's actually right on top of that line. Okay, so that one's no. And if you think about that, these points, if I would plot a bunch of these points here, well, this is 2, 0. If I go up here, it's 2, 1, 2, 2. So you can see that the x values are being repeated each time. Okay, so this is not a function, but it's really easy to do it with a graph, and it's easy to do with points too. You just look to see if the x values are repeated. That determines whether it's a function. Okay, so the last thing I want to do is I want to talk about given a function, and so these are actual functions. So this is new notation. This is called, and you actually say it this way, this is called f of x. So f of x. You will see that actually written out quite a bit. That letter can be g of x, h of x, p of x, q of x, s of x. It can be almost any letter. The letters you really don't use very often are y of x and x of x and z of x. F, G, and H are actually pretty common ones. Okay, so f of x is equal to 2x plus 1. This is really the same thing as saying y equals 2x plus 1. And you're saying, well, if it's the same thing, why don't we just use y all the time? Well, truly what y and x are, they are just points or coordinates on a coordinate plane, on the xy plane. Okay, so life is not full of x and y's. That's when you graph it. But if I want to graph time versus velocity, so I might have t and v. So you don't just always use x and y. What we do is we'll use something called f of x. Now, what this is that x is your input. It's kind of like when you have this problem right here. Usually I say, hey, when x is 5, what's y? And you go, oh, well, I'm just going to put a 5 right into there, and I'll get 2 times 5 plus 1. So it's 10 plus 1 is 11. Okay, so, and your 11 is your output. Well, what this deal is when you have f of x, your x here is your input, as we said already. And what your answer is, your actual f of x is your output. Okay, so it's really not a difficult concept, but you have to understand that whatever, and we'll actually get into a problem, but whatever I tell you x is, that's what you're going to put into this x right here. You're going to multiply it by 2 and you're going to add 1. So it's your input, and let's talk about that. If I said f of 2, that means this is my input. This is my x value, so that goes into that x right there. So f of 2 is 2 times, well, isn't f of x 2x plus 1? So wherever I see an x, I'm going to put this 2 in there. So 2 plus 1. So the way you would say that is you would say, well, let's figure out, it's 2 times 2 is 4, plus 1 is 5. So f of 2 equals 5. Now, please note, this is not multiplication here. This is just telling you you're putting a 2 in for x. This is not saying f times 2. You have to remember that. It's literally f of 2 saying x is 2. Hey, what is f of 2? Well, you stick it in there and you say 2 times 2 is 4, plus 1 is 5. Okay, so let's try a couple other problems here, just kind of make sure you guys are good to go. Okay, if I said f of x equals 3x plus 4. So whatever I tell you, I'm going to put in here. So f of 1. That means you are going to take a 1, because remember this x right here and this x right here are really the same thing. So if that x is, it's like saying x equals 1 here. And so you're going to put a 1 into this x here. So it's going to be 3 times 1 plus 4. So we get 3 plus 4 equals 7. So that's what it is. F of 1 equals 7. Okay, it's a pretty simple concept. It's really not that bad at all. And let's try another one. F of negative 1. Okay, 3 times, well, what's x? X is negative 1. So you put a negative 1 in for x. Add 4. So it's negative 3 plus 4 equals 1. So f of negative 1 equals 1. Now technically, if I did write these as coordinates, I could do that. Remember, that's your x value. And remember, f of something is really the same thing as y. It's like saying f1 comma 7, and this is negative 1 comma 1. Okay? So that's pretty easy stuff. Let's do a couple of them that are a little more complicated. If I did f of x equals x squared minus 3x plus 1. Okay, you have to be really careful in your calculator. If I told you f of negative 2, if you remember from actually way back in the day, and you're plugging things into this x, it's really in parentheses. Negative 2 squared minus 3 times negative 2 plus 1. And now you're just going to simplify it. Now be careful on most of the TI calculators, or most of the calculators, especially when you have 2 lines of display. So 2 lines of display. So basically what you do is when you type something in, you actually see what you're typing in. You type a parenthesis, you see it. You type a negative 2, you type the little up arrow, and you hit the 2. Because remember, guys, this is your exponent. That's on some of the calculators. Some calculators it looks like y to the x. Some calculators it looks like x to the y. So you kind of have to get to know your calculator. But if you have a calculator that does 2 lines of display or 1 line of display, but you can see exactly what you're typing in, that's actually pretty convenient, because you can just type it directly from your calculator or into your calculator. The key here is you got to use parentheses. That's pretty important stuff. So if you type this directly into your calculator with all the parentheses, you would get the same answer. But let's do it by hand, because you guys should know how to do it by hand anyway. It's negative 2 squared. Negative 2 times negative 2 is positive 4. Negative 3 times negative 2 is positive 6 plus 1. So f of negative 2 equals 4 plus 6 is 10, 11. That's it. So let's try another one here. F of negative 1. Again, it's negative 1 squared minus 3 times negative 1 plus 1. So it's negative 1 squared is 1 plus 3 plus 1. So f of negative 1 is equal to 4 and 5. Okay, there we go. So remember, x values are domain. So like for these two examples I just did, my domain is going to be the x values, which is negative 2 and negative 1. The range is going to be the output values, the y values, so it's going to be the 11 and the 5. Okay? So remember, I mean, when you see the word x, or you see the letter x in there, x is your x value normal, and f of x is going to be your range. That's like your y value. Very important. So that's your x value, that's your f of x, or your y value. All right? So that's pretty simple. Just be careful about putting positive, negative numbers into your calculators or calculating them out. Now, the really easy one is if I did f of 0. F of 0 is always my favorite because when you put a 0 in, what happens to the x squared and the 3x? That just goes away, right? It just cancels out. It's 0. And you just have 1. So f of 0 is 1. Pretty easy. Okay? So that's pretty much it for finding the ranges and domains and determining if it's a function based on points or based on a graph, and actually the f of x and h of x and the actual function notation. All right, math fans, that's it. Have a good day.